I'm so glad you're here to join me on another cosmic journey. We often look up at the night sky and see a serene, unchanging canvas of stars. But that tranquility belies a universe teeming with oddities, with worlds so bizarre they challenge our very understanding of what a planet can be. The cosmos, my friends, is a vast and endlessly surprising place, a theater of the extraordinary, and we've only just begun to pull back the curtain. Today, we're going on a tour of the universe's most peculiar real estate. We're not just talking about big gas giants or small rocky worlds like our own. Planets where it rains molten glass sideways. Worlds made of solid diamond. A planet so ancient it was born when the universe was just a toddler. These aren't science fiction concepts. They are real, confirmed exoplanets discovered by our most powerful telescopes. Stick with me as we count down some of the strangest, most mind-blowing planets ever discovered. The universe is weirder than you can possibly imagine, and by the end of this video, you'll have a whole new appreciation for the sheer creative power of physics. Let's get started. First up on our Cosmic Freak Show is a planet with some truly terrifying weather. Let's travel about 63 light-years away to the constellation Vulpecula. There, we find a hot Jupiter named HD 1897-33b. At first glance, it's a beautiful, deep azure blue, reminiscent of our own home planet. But let me tell you, this is no welcoming ocean world. That stunning blue color isn't from water. It's the hue of a turbulent, silicate-rich atmosphere. This planet is tidally locked to its star, meaning one side perpetually faces its sun, while the other is cast in eternal darkness. This creates an extreme temperature difference that drives some of the most ferocious winds ever recorded. We're talking speeds of over 5,400 miles per hour, or 8,700 kilometers per hour. That's more than 7 times the speed of sound. To put that in perspective, the most powerful hurricanes on Earth barely reach 200 miles per hour. Now, what are these winds carrying? This is where it gets truly wild. The planet's atmosphere is laced with silicate particles, the building blocks of glass. The scorching day side vaporizes these particles. Supersonic winds whip them to the cooler night side where they condense. But they don't form gentle clouds. They condense into droplets of molten glass. And because of the extreme winds, it rains sideways. Like a storm of microscopic superheated glass shards traveling faster than a speeding bullet. Astronomers detected this by analyzing starlight filtering through its atmosphere. That beautiful blue we see is literally light scattering off tiny glass droplets. It's a powerful reminder that in space, beauty can be profoundly deceptive. A tranquil blue marble from afar, a hellscape up close. HD 1897-33b expands our definition of weather, and it's one tourist destination you'll want to keep off your list. Next, we journey to a world locked in a slow cosmic death dance. Meet WASP 12b, located about 1,400 light-years from Earth. It's one of the hottest exoplanets ever discovered, and it's getting progressively hotter. Why? Because its parent star is slowly but surely devouring it. This isn't a metaphor. It's a literal, gravitational feast. It orbits at less than 1/40th of Earth's distance to the Sun. A year there takes just over 26 hours. The star blasts its day side to 4,600 degrees Fahrenheit, 2,500 Celsius, hotter than some stars. Molecules in its atmosphere can't even hold together. They're broken into constituent atoms. Immense tidal forces stretch the planet out of a sphere, distorted into an egg, a football, one end locked toward its doom. That stretching generates frictional heat, puffing it to nearly twice Jupiter's size, though it has about 1.4 times Jupiter's mass. The star's gravity is actively siphoning the planet's atmosphere, a river of gas flowing into the star. Hubble observed a massive cloud surrounding the planet, confirming it is being eaten alive. It's losing mass at about 6 billion metric tons per second. At this rate, it could be consumed in roughly 10 million years, a ticking clock. Stripped material looks carbon-rich. Some speculate a carbon planet, perhaps a graphite or even diamond core. As WASP 12b is torn apart, we gain a unique glimpse into a gas giant's interior, a planetary autopsy revealing secrets as it breathes its last. Speaking of diamonds, let's talk about a planet that might be the ultimate cosmic treasure chest. This is 55 Cancri e, a super-Earth about 41 light-years away, orbiting within a binary system, and racing around its star every 18 hours. Its speed isn't what's mind-boggling, it's what it's made of. With about twice Earth's diameter and roughly 8 times the mass, scientists calculated a density pointing to a very unusual carbon-rich composition. Early models suggested enormous carbon content, potentially a layer of diamond thousands of kilometers thick beneath a graphite surface. Being so close to its star, its day side sizzles near 4,900 Fahrenheit, 2,700 Celsius, hot enough to melt rock, perhaps with rivers of lava. On a carbon world, diamond might be just another rock, the equivalent of granite or basalt on Earth. Recent observations complicate the picture. A substantial hazy atmosphere, possibly containing hydrogen cyanide. Other models favor a dynamic volcanic world, with a silicate mantle, still incredibly carbon-rich. Its chemistry is alien, its geology likely driven by carbon. What would volcanoes spew? Carbon dioxide, methane, perhaps even diamond dust. Regardless of exact percentages, 55 Cancri E is fundamentally different from our world. A sparkling, fiery testament to cosmic creativity. Now, let's take a journey not just through space, but through time, to M4, about 12,400 light-years away. Here we find a planet nicknamed Methuselah. Officially, PSR B1620-26b, the oldest known planet in the universe. It's about 12.7 billion years old. The universe is about 13.8. This world formed when the universe was under 1 billion years old. Back then, heavy elements like carbon, oxygen, and silicon were scarce, forged in stars and spread by their deaths. Its discovery challenges our timelines for planet formation. It's a gas giant about 2.5 times Jupiter's mass, able to form with minimal rock and ice. But it doesn't orbit a normal sun. It circles a bizarre binary pair, a rapidly spinning pulsar, the remnant of a supernova, and a white dwarf, the collapsed core of a sun-like star. Leading theory, it formed around a normal star, then drifted close to the pulsar. In a gravitational dance, the planet was captured into its current orbit. Imagine two suns in the sky, one a tiny dim white dwarf, the other an invisible pulsar revealed by rhythmic flashes. A sky completely alien to ours, over a system that has witnessed almost the entire history of the cosmos. Methuselah is more than a planet, it's a fossil, a relic from the dawn of time proving that the drive to form planets began almost as soon as the first stars lit the darkness. From the oldest to the wettest, at least potentially. Let's set our sights on GJ1214b, another super-Earth about 48 light-years away. Nicknamed the Water World, it might be a globe-spanning ocean, but not an ocean like Earth's. At about 2.7 times Earth's diameter and 6.5 times the mass, its density is too low to be rocky and too high to be a gas giant. Hubble saw a thick, steamy atmosphere, a planetary-scale sauna. Leading models suggest a small rocky core surrounded by a massive global ocean. We could be talking hundreds, or even thousands, of kilometers deep. Earth's deepest trench is only about 11. Close to its star, surface temps may reach 450 Fahrenheit, 230 Celsius, above water's boiling point. Immense pressure changes water's behavior, creating exotic phases, like hot ice, or even superfluid-like states under extreme conditions. Picture a rocky core, wrapped in hot ice, topped by a global liquid ocean, beneath a dense steam atmosphere, H2O in all three states at once. JWST is sharpening the view. Early results hint at hazes or clouds not of water, but possibly potassium chloride or zinc sulfide, obscuring the vapor below. The science is a detective story, with clues gathered piece by piece. Still, the possibility of a true water world, more ocean than rock, remains one of modern astronomy's most tantalizing ideas. For every Star Wars fan who ever gazed at twin suns and dreamed, the universe has an answer. Meet Kepler 16b, the first definitively confirmed circumbinary planet, a world with two suns. Two stars orbit each other, one a K-dwarf, the other a red dwarf, completing a dance every 41 days. Circling both in a 229-day orbit, Kepler 16b is Saturn-sized and cold, around -100 Fahrenheit. Kepler saw the stars eclipse each other, and a third, fainter dimming as the planet sometimes transited one star, sometimes the other. Timing wobbles nailed the orbits. Imagine a moon there, two suns moving across the sky, sometimes close, sometimes far, double sunrises, double sunsets, and two shifting shadows. Astronomers once thought two-star gravity would disrupt planet formation. Kepler 16b proved planets can form in complex binary environments. Many stars are in binaries, vastly expanding the potential real estate for life. The double sunset is not just a fantasy, it's a cosmic reality. Our final destination is a world shrouded in almost absolute darkness. It's so black, it absorbs nearly all the light that falls on it, darker than fresh asphalt or a lump of coal. Welcome to Strangest 2b, the darkest exoplanet ever discovered, about 750 light-years away. Most planets reflect some sunlight. Jupiter over a third, Earth about 30%. Strangest 2b reflects less than 1%. It orbits close to its star, roasting over 1,800 Fahrenheit, 980 Celsius, hot enough to glow, but only a dull cherry red. Its darkness must come from the atmosphere. Instead of reflective silicate clouds, it likely harbors gases that trap light, perhaps vaporized sodium, potassium, or titanium oxide. At those temperatures, these remain gaseous and absorb across visible to infrared, forming a planetary-scale light sponge. You wouldn't see it by reflected light, only as a circle of pure blackness sliding across its star. No swirls, no colors, just a featureless, matte black orb glowing faintly from its own heat. It defies expectations. Not reflective, not bright, not colorful. The void given planetary form. Strangest 2b is a cosmic ghost, a shadow drifting through space. Proof that atmospheric chemistry can yield outcomes we never predicted, even in a universe awash with starlight. And there you have it, a journey to some of the most bizarre and bewildering worlds our galaxy has to offer. From a planet of glass rain, to a diamond world, from a cosmic fossil older than Earth, to a real-life Tatooine. Each of these discoveries pushes the boundaries of our knowledge, and forces us to ask new, more profound questions. What else is out there? What other planetary marvels are waiting to be found in the cosmic dark? The search is what drives us. The mystery is what inspires us. These worlds are physics playing out on epic scales. They remind us our precious blue planet is just one outcome among countless others, granting perspective, humility, and awe. So, what was your favorite strange new world? Was it the terrifying glass storms of HD 189733b? Or the ghostly darkness of Strangest 2b? Please like and subscribe. Thank you as always for your curiosity and for watching. Keep looking up.